Greetings of the day. Welcome to the course on Operations Research Technique. In last lecture, we have studied overview of operations research. We have studied various definitions of the operations research, and we have started with unit number 1, linear programming. And in that, we have seen what is linear programming, what are the essential conditions that must be satisfied by the problem which is to be solved with the concept of linear programming. We have seen essential conditions and requirements for the problem to be solved with the concept of linear programming. So with now we will be taking brief recap of those conditions, and we will move forward for mathematical formulation of linear programming problem. I hope you got insight into operations research and what is linear programming in our last lecture. So let us begin today's lecture with recap of what we have studied in the last lecture. So if you recall, our last lecture was based on various assumptions, and we have discussed various assumptions in LPP. I have explained those assumptions with the help of examples. We have seen various assumptions like proportionality, additivity, continuity, and certainty. Along with this, we have also seen further conditions to be satisfied by linear programming problem if it is to be optimized by the logic of linear programming. So we have seen in that there must be well-defined objective function, there must be alternative course of action, resources must be available in limited supply, there must be constraint on the amount of objectives, attainment of the objectives, and decision variables should be interrelated and non-negative. We have seen these parameters in very much detail. Now we will move to the main aspect of linear programming, and today first we will understand how generalized linear programming problem is and what are the elements, various elements of that generalized linear programming problem. So as you can see here, as also mentioned in my last lecture, we have seen this. It is either minimize or maximize, or condition is essential at a time. You cannot have both objective function in the same problem. It will be either minimize or maximize, and we are representing that function by mathematical function by symbol Z. It can be any symbol, but most of the authors, they are using the symbol Z. And this particular objective function, maximize or minimize, depending on the target, whether my target is say profit or my target is say cost, for example, it will vary. If it is problem pertaining to profit optimization, my intention will be to maximize profit. If it is the problem pertaining to cost, my intention will be to minimize the cost of production or whatever related quantities. So depending on your objective function target, this mathematical function will either take the form of maximize or minimize. Now in last lecture I have mentioned that these B1, B2 up to Bm, these are various resources which are required in the problem to attain the objective function. So for first resource, equation ends with B1, for second equation ends with B2, like for Bm, mth resource, it ends with Bm. And here you can see three variables, three logical relationship, less than equal to or greater than equal to. Remember, at one time, whenever we are writing any equation, it will be presence of only one this is very important, only one out of these three. For example, if I am writing 3x1 plus 2x2, I can write either less than equal to 10 or greater than equal to 10 or equal to 10 depending upon the constraint availability. So at a time there won't be three logical signs, there will be only one sign, that you have to keep in mind. And here these x1, x2, xn are decision variables in the problem. Suppose we are interested to find the value of amount of product to be produced, then we have to assume something like let x1, x2, x3 be the number of units of particular product in the view of maximization of profit or minimization of cost. And these A's, like these A11, A12, these are called as, here I have mentioned, these are called as technological coefficients, or other name to that is structural coefficient. Like in this example, this 3 is representing, say, A, I, J. I is for rows, J is for column. Similarly, this 2, this is also representing the value A, I, J. So the meaning is now very clear. 3x1 plus suppose 2x2 less than equal to 10, I am writing this 3 and 2 represents A's, whereas that 10, this 10 is represented in the form of B's. So it will take value from Bi to Bm. Here I have written I ranging from 1 to n, 1 to m, and j is ranging from 1 to n. So B's are nothing but resources. Now this is a lengthier form. Suppose we want to write this particular equation in condensed form, then this plus means it is summation. So we have written it is summation of j ranging from 1 to n, all addition of cj and xj's. So therefore cj, xj, this is multiplication of these two parameters, and addition of that is summation. So this is given in the form of target or objective function, that is minimize or maximize. And all these constraint equation are written in generalized form as summation j ranging from 1 to n, aij, xj greater than equal to bj. And last, this is very important, non-negativity condition, all decision variables are greater than equal to 0. So students, this is generalized linear programming of any given situation in mathematical form, in the form of variables a, j, c, j's, x, j's, like that. And now we will look into deeper aspect of how we can form these formulated version of the problem from given data, that we will see. So hope this is clear to you, how linear programming in totality can be expressed in general way, and from this general way we will get idea that how to frame linear program for a given situation. Now we will go into details of that, and we will see one by one application of all these concepts in real life or real domain. So further, now if I want to form or formulate the problem in the capacity of linear programming problem, I have to follow some steps. Data will be given in the form of wordings. The company or organization who want to optimize rather maximize profit or minimize cost will be having their entire collection of data in the form of wordings, in the form of sentences suppose. So we have to interpret those sentences, and based on those sentences we have to formulate the problem. So before that, how we should be ready to understand what are the findings, what findings should be there from the problem. So here the steps are given, various steps are given, like step 1, identify decision variable. These are very important parameters now, and we have to meticulously follow all these steps. Identify decision variables. Unless and until we carry out this particular process of identifying decision variables from the given data, we are unable to formulate the linear program for the given situation. So here in general it begins with, we generally like that we'll write further, let, we assume something, let x1, x2, rather up to suppose xn be the number of variables for related quantity. That is what we are assuming in identifying decision variables. This is very first step when we talk of formulation, model formulation in linear programming. First step, very essential step. Second, identify problem data. Whatever problem given to you, in problem data you have to identify various resources available to you, because without resources, and that too without limited amount of resources available, we cannot proceed forward. If you want to produce something, then you must have amount of raw materials required for production of those quantities in the form of finished goods. So you have to identify the various resources available from the data, and therefore the second step is identify the problem data. Once you identify variable, when you thoroughly identify all problem data, then next is formulate the constraints, because we have seen in the very first lecture that LP deals with availability of resources, but that too within limited quantity. Means when anything is available in limited quantity, in technical term it is referred as constraint availability. There are restrictions on the availability of things. And last is formulate the objective function. Formulate the objective function. Again, this objective function means you have to either maximize or you have to minimize. When we talk of formulation of objective function, only two aspects, either maximize or minimize. And we have seen in first lecture that if it is profit to be maximized, if it is production capacity to be maximized. For minimization objective function, definitely it has to be cost, it has to be minimize lower maintenance time or reduce inventory or likewise parameter. So depending on the data given, we have to formulate the objective function. Remember, students, what you have to remember in mind is directly what is the objective function may not be given many a times. First, you have to read the data, you have to interpret various parameters, and depending on the given parameter, you have to decide whether that is to be, this objective function is to be maximize or minimize. In some problem, one may give you solve this for maximization of profit, solve this linear programming for minimization of profit, like that. But as an engineer, we should be in a position to smell the data, interpret the data, and based on the data we should be in a position to formulate whether it has to be for maximization or minimization. I think this is very clear. Now let's go into deeper aspect of this formulation. Once we are ready with guideline, again before going to the problem, let me explain one thing again that is very much important. When we are putting constraints, we have to put logical relationship like this, or we have to put logical relationship like this, or we have to put logical relationship like this. This is very important. Understand the concept first. Means when we want to frame any linear programming problem from the given data, in different equations we have to use either of this sign, any one of this sign. Means either less than equal to, greater than equal to, equal to. So now I will give you jugglery of words, how to interpret those words, and based on the words how you should be in a position to select which particular logical sign should be used in formulation. If these signs are wrong, then our entire efforts goes to waste. If instead of less than equal to I write greater than equal to or even equal to, I will commit mistake in attaining the final goal. Now we'll go into understanding of this particular problem. Say for this, I will explain this by a simple example. Suppose I say, listen this example very carefully. Suppose I say that I am having 100 rupees with me. Right now I am having rupees 100 with me. This is my plain statement. I am having rupees 100 with me. In other term, if I am saying I am having 100 rupees with me, means definitely I am having rupees 1, I am having rupees 10, I am having rupees 50, I am having rupees 99, I am having rupees 100. But remember, I am not having rupees 101. So maximum how much rupees I am having? What is 100? Maximum 100. So I can express this plain sentence as I am having less than 100. I am having I can express this situation as I am having less than 100 rupees, because 1 is less than 100, 10 is less than 100, 99 is less than 100, 100 is equal to 100. So this less than equal to sign suffice. Got it? I cannot write I am having greater than equal to. I cannot write. If I write this, I am having greater than equal to 100 rupees, means my assumption, my mathematical conversion is wrong. So one thing in mind, when data is given in the plain form, the maximum availability of raw material is, when it is in the plain form, maximum availability is means that is the upper limit. If upper limit is available to you, means you can have any value ranging from 0 to upper limit. So for plain text, availability of raw material is 5 tons. Means maximum availability of that raw material is 5 tons. So which sign you will use in that case, students? Yes, think. Definitely it has to be less than equal to sign. Got it? Or other thing, if English word like not more than, the availability of raw material for the task is not more than 100 kgs, not more than, focus on the word not more than, means maximum, suppose I am saying 100 kg, maximum is 100 kg, not more than 100 kgs, so maximum is 100 kgs. So again the sign will be less than equal to. So when the plain condition is there, maximum availability, sign to be used is less than equal to. When it is given not more than fashion, again less than equal to. I think explanation is very much clear to you. Now suppose we want to use this sign greater than equal to. The minimum required quantity for, or the minimum required amount of raw material is, suppose it is given in the form of minimum requirement, it is given like this, minimum requirement of raw material, word is minimum, minimum requirement of raw material X, or rather A, is suppose 10 kg, means minimum 10 kg, anything over and above 10 kg is welcome. So the sign used will be greater than equal to. Or other word for this same is at least requirement or requirement of raw material to be satisfied is at least 5 kg, at least. Again that at least word is focusing or taking you to minimum. When it is taking you to minimum, sign has to be less than equal to. So if it is plain text, availability of raw material or maximum availability of raw material or not more than, use sign less than equal to. If it is in the form of minimum availability or at least requirement, use sign equal to. This is first, this is second. Now when to use third condition, equal to. That is very important. There are certain instances where for a particular product it is very much essential that you are not supposed to exceed the quantities of ingredients to be added in the final product, and the condition is specified then, like by using word or stressing words like standard weight of, suppose the condition given to me is standard weight of a product is 10 kg. Standard weight of a product is, suppose it is given 10 kg. I have to use in this case only sign equal to. There is no scope of using sign greater than equal to or less than equal to. If this is the specified condition, then sign has to be equal to. Or the condition is such that it is stressing by some words, must, like word like, suppose must. Suppose they use the word must in the problem definition. Again we have to go for logical sign equal to. So I think students, now you are very much clear in your idea regarding which sign, whether less than equal to, greater than equal to, or equal to be used in formulation. At a time only one. At a time only one. Is it very clear? If this is clear to you, now let us move to the very first step of solving linear programming problem, and that first step is referred as formulation of the problem from the given data. Formulation of the problem from given data. So till now what we have studied is various requirements for a person to be known to formulate the data from a given information in the form of linear program. Now we will go one by one and we will see how to formulate by using all these logics the linear program for a given situation. Listen, keep these steps in mind. Identify decision variable, identify the problem data, formulate the constraint, and formulate the objective function. These are keys to formulate the problem. Got it? These are the keys to formulate the problem. Now read this problem. Read this problem carefully. Read it from very first word to last word. Then I'll ask you some questions. And if you answer those questions, answer of those questions itself is half done formulation of the given problem. Read it carefully. Take some moment. Okay, you might have read the problem. I will now read it and highlight the things. The problem reads as: a company manufactures two types of pens. I will simultaneously go on underlining the things. A company manufactured two types of pens, their name alpha and beta. Alpha and beta is the name of the product which that company is producing. Then important condition is given. This pen which is manufactured, it requires the resources. First resource is labeled as R1 and other resource is labeled as R2. Being first problem, instead of giving directly the name of resource used for manufacturing of pen, we have used R1 and R2 term, replicating resource 1, resource 2. This is very important. Each unit of alpha requires 1 unit of R1. Each unit means one pen of alpha needs 1 unit of R1 and 3 units of R2. Remember, see here, the organization is making two types of pens, alpha and beta. Both pen needs both raw material in the form of resources labeled as R1 and R2. But important, their quantity, amount required of those resources for pen is different. Like for alpha pen you need 1 unit of R1 and 3 unit of R2. Whereas I will now mark with other pen, each unit of beta needs 1 unit of R1 and 2 units of R2. Here it may change, but it is given same. But for beta it needs 2 units, and for alpha it needs 3 units of R2. This data should be interpreted in a very nice way. Manufacturer has 5 units of R1 and 12 units of R2. Very important. This is very important data. Think of. Can you tell me what this data belongs to? Just think for a few minutes. 5 units of R1, 12 units of R2. What is that? Can you answer? Think. Yes, your thinking is probably correct. If it is, maximum availability of R1 is 5 units. Resource R1 is available maximum for 5 units, and resource R2 is available maximum I am saying for 12 units. If you have thought in that way, you got some insights to the linear programming. Now important again, the profit contribution per unit of alpha and beta is rupees 6 and 5 respectively. What is the meaning again of this? Think for a moment. Profit contribution per unit of alpha and beta is rupees 6 and rupees 5 per unit respectively. Meaning, if the manufacturer produces and sells these products in the market, he will earn rupees 5 per unit on alpha and rupees 6 per unit on alpha and rupees 5 per unit on beta pen. Hypothetically, suppose we say that he sells, hypothetically I am saying, 5 units, then 5 into 6 is the profit earned by manufacturer, and suppose he sells 10 units of beta, so 10 into 5, 50 rupees is the profit earned by manufacturer. This is the entire problem given to the OR specialist, operations research specialist, for determining the optimal product mix. In first lecture, we have seen various applications, possible areas of application of linear programming, and in those applications, one of the application was deciding optimal product mix. Now this is a unit which is producing different types of pens. So depending on the scenario in the market, he has to decide how much to produce of each type. Now see here, dear students, it is very important. It is not mentioned in this particular case, it is not given to you what is the objective function. It is not given to you. Instead, what is mentioned is determine optimal product mix. Plain wording is there. I have narrated this in my earlier slides. You have to smell the problem content, and from that you have to decide what should be the objective function. It will be either maximize or minimize, but which is that parameter which is focusing what to maximize. Production capacity, profit, or what to minimize? Cost, inventory, delay, maintenance time, inspection time, like that. Now here, can you tell me what should be the objective function? What will be the objective function in this problem from operations research linear programming point of view? Looking at the wordings given in the problem, can you just guess, sir, this is the objective function in this particular problem? Anybody? Think? Yes. Got it? Very good. What is in your mind? It's minimum or maximum? Yes. If it is in your mind, if it is maximum, maximize, you are correct. Why? Because in this particular problem, the profit contribution is given per pen, which indirectly gives you the idea that here we must maximize profit. Now, before that, we have to assume something. That is very first step, identify decision variable. Students, here products are labeled as alpha pen, and other type of pen is beta pen. Alpha pen and beta pen, 2 pen, and I have to decide the optimal product means. Meaning of this optimal product means is how much of alpha I should produce, how much of beta I should produce, from logic of operations research. I have to decide how much alpha pens to be produced, how much beta pens to be produced. How much quantity, that is nothing but determining optimal product mix. Now remember one thing, students, in mind, whenever you stuck up with this situation, any given situation, that you want to find something and your starting is question mark, how much to. So in that case, what you have to do is you have to start from your assumption, and you know, in assumption we write let. We assume something. So what we will do, let x1 be the amount of, or be the quantity of alpha pen to be produced, and x2 be the quantity of beta pens to be produced. Got it? I'll start my problem from this scratch position. This is called a scratch position. I don't know anything. I want to produce, I want to find the quantity. But to end with some value, calculated value, I have to start from some base. And base is assumption. And in that assumption, what I am assuming? Let x1 be the amount of or quantity of alpha pen, and x2 be the quantity of beta pen. This is one part. Other part, we should read problem carefully, very carefully. This is possible, this production is possible only when you are having resources. How many types of resources you are available? Here, being the first problem, I will write contents on the same slide. Okay? And from next problem, we will go on different slides. Now, as given here, we are having resources R1 and resources R2 with us. Okay? This is summarizing. What I am doing now is summarizing. What I am doing right now is summarizing the problem data for formulation. This is summarizing. This is not exactly formulation. Making me aware what are the various inputs to the problem, taking all those inputs at one point, one time, at one location, and then building the formulation. So R1 and R2 are two resources required for alpha and beta pain. So here what I will write is alpha pain. Here I will write beta pain. See what I am doing? I am summarizing all these values in this form, tabular form, for further formulation. I want to produce some quantity of alpha, I want to produce some quantity of beta. These require resources R1 and R2 in varying proportion, and I know I enjoy some profit after manufacturing of these pens. See here what I am doing. Profit in rupees per unit. This is given to me. For alpha pen I am earning rupees 6 profit per pen. For beta I am earning rupees 5 profit per pen. Now here important, each unit of alpha requires 1 unit of R1 and 3 units of R2. Alpha pen requires 1 unit of R1, 1 unit of R1, 1 unit of R1, 3 units of R2, 3 units of R2. Can you tell me likewise what I should write over here? Think. Correct. Your thinking is correct. In the line. Beta. Each unit of beta requires 1 unit of R1, beta R1, 1 unit of R1 and 2 units of R2. Most of the information given I have quoted in the form of summary. One important information is missing yet in this summary table. Can you guess? Anybody from the class? Any student who can guess what is missing again in this table? Yes, right. It is the amount of resource R1 and R2. Now you can see here maximum availability of R1 given here is 5 units. So I must write here below R1 total availability is 5 units, and for R2 it is given maximum is 12. Now we are ready with all relevant information. Summary is ready. Based on this summary now we will construct the table. See here, I have said that to begin with I have to assume something. So I am assuming x1 units of alpha and x2 units of beta pain. So here before alpha what I will write is x1 and for beta I will write x2. Now this given table is the complete table for our model formulation. What I did here is I have brought all this information in a tabular form, and once this is correctly brought in the tabular form, I can write formulated version in this form. It is given like this: identify the steps, decision variable, formulate the constraint and the objective function. So we are ready with this particular aspect now. So whatever we have discussed till now, we have narrated all given information, we have converted that all information into the desired problem, desired tabular form, and now after identifying all these parameters, in next lecture what we will do is we will put that in desired linear programming format, and we will go in the similar fashion with other categories of example. I think you got some insight in the today's lecture. So in next lecture we will continue with further part of formulation of the problem from the given data. We will continue with the same problem and go ahead to the other problem. Rest, practice the problem.